All right, as a reminder, your next homework assignment is due on Friday the 11th. And to let you know, the homework grader is providing comments. When your homework is graded, it's more than just the score itself. There's written comments that you can get at they'll pop up next to the score. And then also, if you open the PDF file, occasionally the grader will actually put annotations in your assignment. So it's kind of like using sticky pads, or the grader is able to write notes directly on what your work is. And occasionally he'll do that to draw your attention to maybe a certain part that you did wrong, or if there's a mistake in your work. So definitely, since you've taken the time to do the assignment, you should take a few moments after each one is graded to close the loop and see what you did right, what you did wrong. And I think from the feedback the grader provides, you'll be able to correct your mistakes. And I think that's a great way to prepare for the exams. Is any place you got something wrong, don't leave that mistake uncorrected. Just take a couple of minutes, go through and fix your mistake. And if there's something you just still don't understand what you did wrong and can't figure out how to do it correctly, of course, get in touch with me. We can have a meeting over Teams, and I'd be glad to go over that with you. All right, so your next assignment's due on the 11th, and that's homework number 2. Today we're going to talk about interest factors. And in a previous lecture, I pointed out to you that in the back of our book, there are these factor tables, where it's just page after page, row after row of different factors. And it's a way to solve time value of money problems without having to know or use the equations for like a F/P, A/F, and so on. Remember, we talked about the way to summarize problem types with a standardized notation. Oh, hold on. Homework is due on the 11th. All right, so yeah, Friday. So this is an equation list that so far we've seen some of these formulas, others won't be introduced until later. And so, for instance, you've seen on several occasions that you can find a future amount, that the ratio of F to P is 1 plus I to the n power. And so if you know a present value, let's say that you have $100 now, and you want to find out what will be the future value of that, then you would move the P from the denominator of that ratio over to the right side of the equality, multiply it by the result of what's in the parentheses there, and then that would tell you the future amount. And so if you want to find the present value from a future amount, here's the formula for that. And just each row has a different set of formula that you can use in order to find the unknown. And so in our standard notation of having like F/P, P/F, it's always the unknown that goes first. And so it's find F given P, find P given F, find A given F. And this column kind of tells you, when you're given something, how you're going to find the unknown. And then each of these different problem types has a name as well. Rather than solving these equations, you can go into the back of the book and other sources like the reference manual for the Fundamentals of Engineering exam. Many of you, hopefully all or most of you, will take the FE exam maybe in the last semester of your time at Marshall. It's the first step to becoming a licensed professional engineer. And the FE exam kind of is designed to identify who are the students that are competent and ready to enter the profession. And there's a reference manual that has a lot of the equations that you're going to learn during your engineering career. And it also has these factor tables, because there's a lot of questions in the FE exam related to engineering economy and the time value of money. And so what this table illustrates is they're solving these equations for different n values, and all of these are I equals 8%. So for example, the F/P, what they did was they said for the first row, n equals 1, and I is 0.08. And so you can just do that math in your head. 1.08 to the n power, where n is 1, it's going to be 1.08. So here is 1.08. For n equals 2, what you're doing is you're taking 1.08 to the second power. And so it's 1.1664. And that extra amount on the end there is because of compounding. It's the intermediate quantity in years before the final year. The interest amount is being compounded. And so for each of these rows, what it represents is the n that's going into the formula for f slash p. And so likewise, here is p slash f, and you can see that the factor is getting smaller and smaller and smaller. And so think about what that means. That means that if you want to find the present worth for $1 in the future, so if someone gives you $1 10 years from now, then the present worth of that dollar, if it's being discounted at 8%, is only 46 cents. So remember, when we've talked about the two verbs, compounding money into the future and discounting money from the future back to the present, compounding gives you the idea that the amount is getting bigger and bigger. And so that's what this column illustrates, is if you have in time 0 $1, and then that money stays in the bank and continues to earn interest every year at a rate of 8%, you can see that after 10 years, that $1 has turned into $2.16. So that's what the first column is compounding of a single amount over time to some new future amount. Likewise, the present worth is, those are both single amounts. They're not an annual recurring series, but it's a single present value we're trying to find based on a known future amount. And so here is the effect of time on the value of money. Now A slash F, that's finding A, an annual amount, based on some known future value. And each one of these is solving the equation for the row in question, that's the n, and the I. All of this was for an I of 8%. And different pages in that table in the back of your book has different interest rates. There's a 0.25%, 0.5, 0.75%, 1%, 2, 3, 4. So you can find factor tables for a lot of different interest rates. All right, so let's just, before we get into the in-class exercise for today, let's take a look at an example together. Someone's depositing $5,000 into an account that pays interest at a rate of 8% per year. The amount in the account after 10 years is closest to. All right, so if we summarize what kind of problem this is, sometimes it's a good idea just right there on the page where you find the problem to identify the variables. So if you're doing that, then you would say P equals 5,000, I equals 0.08, N equals 10, and then what is it that we're trying to find here? The amount in the account after 10 years. And so that is a future value. So F equals unknown. So find F given P. All right. So we want to find F given P. There's a deposit. The arrow down means that we're making a deposit, and then in the future we could make a withdrawal of a certain amount. So back to the table on the previous slide, let's find out if we can find which factor we should use. Okay, so back to the 8%. So we want to find the future, find F given P, and was it for 10 years? So 2.1589. Let's see. Find F given P. All right. So 2.1589 is the factor. multiply that by 5,000. Now I won't be able, I can hear that somebody just typed a comment, but since I don't have a second screen today, I'm not able to see those comments or questions, unfortunately, unless I close the presentation and quickly look over at it.
Let's see. It was just
a guess of the answer, probably?
Yeah.
All right, thank you. Yes, good start. Okay. The answer is C. All right. So that's how we can use the factor tables. Now, hold on a minute, though. Look at the factor. 2.1589. So how many significant figures are there? 1, 2, 3, 4, 5. So what that means is that my answer is only going to be accurate to 5 significant digits. So 1, 2, 3, 4, 5. So here I've reported the answer to the nearest penny, but we can't really do that with these factors. We can only report it to the same. At the very end, you have to round off to be consistent with the number of digits that was in your factor. And so I'm going to correct this and just change it to say 5. All right. We should be accurate to the nearest penny when we're solving the formulas ourselves, but when we're using the factor tables, we have to just look at how many digits were there in the factor. And sometimes there's 5 digits, but not always. If you look over here at some of these factors, for example, the present worth column, there's only 4 digits of precision there. So, how many digits you round off to depends on the table that you use. All right, so let's look at a similar example. Finding the present value. Okay, a company wants to make a single deposit now so it has enough money to purchase a backhoe costing $50,000 5 years from now. Okay, so F is 50,000, and they want to have enough money so that they can purchase that. So that means that they'll be withdrawing it from the bank in order to purchase the backhoe. So if we're going to think about representing this as a cash flow diagram, we're going to deposit in the present. So that's an arrow down at time 0, and then an arrow up in 5 years. So at n equals 5, the arrow is up because we're taking the money out of the bank and then spending it to buy the backhoe. I is 10%. Okay, we don't have a 10% table shown. If you've got a textbook, then open it up, and I'll do the same. I do have a 10% table, I'm thinking, in this textbook here. All right, so I've got it open to that page. So what we're looking for is n equals 5. So I'm going down to the 5th row in my 10% table. And this is find F given P. Find P given F. That's right, because we know the future amount is going to be 50,000. So how much do you have to deposit now in order to have that available? So you don't have to deposit 50,000. We know it's going to be less than 50,000. If we're just thinking about this, eliminating things, we can eliminate D, because why would you need to deposit 319,000 now to have 50,000 available in the future? The whole point of depositing money now is that it's going to earn interest along the way. So let's eliminate D, and you could probably eliminate A just because, boy, how often would it be like a nice round number like that? That's a distractor if I ever saw one. It's maybe someone who is just dividing the 50,000 by 5 years and not really understanding the problem. So it's either got to be B or C. So the factor that I got from the book here is 0.6209. So here's graphically representing what's happening. Deposit how much now? Compounds at 10% a year for 5 years, and we withdraw 50,000. These cash flow diagrams really are a nice way to visually summarize the problem, aren't they? Hopefully by now they're starting to get pretty familiar to you, and it's just so much less cluttered than the English language for summarizing what's happening. So these word problems are less efficient than representing what we're trying to do with the diagram. Okay, so here's the factor. Like I mentioned, 0.6209. You can look that up off of the table. Now look at in the parentheses here. What we're saying is this is the form of the solution. The present value is the future amount multiplied by P/F, I, and N. So what this is a way of doing is now we're going to substitute in I is 10%, N equals 5, and rather than just writing the final answer on the paper, and maybe it's right, maybe it's wrong, it's such a great idea for you to get into the habit of writing a kind of a step-by-step solution where you're showing that you knew, for example, that this is find P given F type problem, that you knew I is 10%, that you had interpreted N equals 5. So take the extra time to kind of show the steps in the solution. Now here again, it looks like I'm going to need to correct this answer because 50,000 multiplied by 0.6209. So if you do that in your calculator, I think what you'll get is 31,045, but then we need to round it to 4 significant figures. So the answer here, 3150, just acknowledges that if you round it to the nearest 4 significant figures, then it's going to be $31,050. So that's how much you need to deposit now. Before we move any further, are there any questions so far on this problem?
On an exam, would you give us like the chart that would be on the back of the book, and we would have to find out from that chart what we would have to use?
That's a great question. So what would I provide in an exam? My typical practice is that I provide 2 things. I would provide this page, so it has all of the equations, and then I would also provide several of these different interest rate tables. And so, if you have a problem on your exam that uses the 8% interest rate table, I'd give you the 8%, the 6%, the 4%. I wouldn't just only give you the 8%. I'd give you a few of the ones that you don't need, just hoping to catch someone who, didn't check. I want to make sure that you're able to get the right table, the right row, the right column. So I do provide these in an exam scenario, and so you wouldn't be expected to provide the factor tables yourself.
Very awesome. Thank you.
All right. Well, are there other questions about this particular example before we do some additional practice with today's in-class exercise? All right. So let me bring up today's in-class exercise. It's in-class exercise 7, interest factors 1. That is the one that we're doing here. And so here is the first problem. That's not right. All right. So what you should do is, if you've printed it out, this first problem is basically just kind of drawing a cash flow diagram, summarize it in this format that we talked about in the second example, and then from the formulas that are on the back, if you turn to the back page, the last page here. So what it's asking is, in order to solve this problem, which of these equations would you use in order to calculate the factor on your own? So that's B. And then C is calculate the factor using the equation, and then solve for it with the factor that you have just calculated, and then also solve for it using the 8% table, which is provided here. Okay. Now I have it solved on my paper here, but I'm going to need to scan it because I was looking and I couldn't find where I'd already scanned it. So while I pause and give you some time to solve this in-class exercise, I'm going to make my PDF so you can see the solution that I've put together. And feel free to interject if you have any questions. You know, while we're working on these, ordinarily in a normal semester, you'd be pairing up with other students, talking it over with them, seeing if they got the same answer that you did, maybe raising your hand and asking me a question. So, you know, I don't think that we have to be silent as you're working on the in-class exercises. You can type, chat messages to one another and ask me stuff. So let's go ahead and solve this one. All right. So you get $50,000 in 7 years. How much is that worth today? So you can see the cash flow diagram that I've drawn as I'm saying receiving $50,000 in the future is the same as receiving how much now. So you'll notice that both of those arrows are on the top side of the cash flow diagram. And that's because this is not one of the problems where I'm depositing a certain amount now and I want to find out how much could I withdraw in the future. These are both receipts. This is a $50,000 inflow 7 years in the future is equivalent to how much of an inflow today. So both of those arrows should be on the top half of the cash flow diagram. You'll notice the labels are on there as well as the interest rate. So that's our cash flow diagram. Now, summarize the problem in the form of question/question. So that means, you know, what are you finding and what is the given? So you'll see here I've said find P given F. So P/F means find P, which is our unknown. And the indicator on the cash flow diagram that it's the unknown is the dashed arrow and the question mark next to the label. So find P given F for an interest rate of 8% and an N equals 7. And by the way, it's okay if you want to have 0.08 or to leave it as 8%. Boy, my computer's just doing some really crazy stuff right now. Is everybody still able to see this stuff? Still with me?
Yes, we're still with you.
Thank you. It's nice to have that confirmation that I'm not just speaking now to a computer that's all messed up. All right, so this is how we summarize it. And then, okay, B is choose from the list provided, write the formula that you should use to calculate your factor. So the list that was provided is all of these formulas. So which of these formulas do you use to calculate your own factor? So this is where we are going to find P given F. So P/F equals 1 plus I to the negative 1 power. Oh, no, not that. Yeah, so P/F equals 1 plus I to the minus N. So now calculate the factor. So we substitute in 0.08 for our interest rate. N is 7. So our factor will be 0.58349 ... What I mean by those dots is it continues. And so what I mean by that is it's not exactly 0.58349. You know, it's some number that continued, and I kept all of that precision in my calculator. It's just I didn't choose to continue writing the digits on and on and on. But I know them, they're in my calculator, and since I have all that precision, when I do solve for P, I'll be able to report that to the nearest penny, because when you're using the equations, then you can be accurate to the nearest penny. And then that's what I did here in part D. So part D asks to solve the problem using the factor that you compute by the equation method. So the present value will be the future 50,000 multiplied by that factor. So what that tells us is that you can either get $29,174 today or $50,000 in the future. Those two amounts are economically equivalent if we have an interest rate of 8%. So it makes no difference as long as your interest rate is 8%. Now finally, what if we use the table lookup method? Okay, so this was the factor that I calculated, but if you go to the table that's provided, the 8% table, so it is n equals 7, so here is the row, the 7th row, 0.5835. Alright, so 0.5835 would be the factor that's there. So it's roughly the same amount, 29,180, but it's not accurate to the same degree that is accurate if you use the equation method. So those are two different approaches to solve for the same thing. Find the present value either with the equation method or with the factor method. So the factor method is sometimes also called the table lookup method. And so if I ask you to use the table lookup method, that means don't use the equation. It means go find the correct interest rate table and find the correct factor that goes with it, and then just multiply the given factor by the amount that's known. So any questions about that first problem? All right, well, let's look at problem 2. Problem 2 says that okay, we've got this cash flow diagram here. Find P. Use the table lookup method. So we know that P is the unknown, not only because it says to find P in the problem statement. That's, I guess, one pretty good clue. Another is the fact that it's the unknown on the diagram here. The dashed line, the question marks, that tells us that we want to find the present value of that annual series. And so what it's saying is, how much do you have to deposit today, right now, in order to make 3 equal withdrawals of $12,500 each if, after you make the deposit, it continues to earn an annual interest of 8%. All right. So let me pause for a moment. Use the table lookup factor to find out what is P. Okay, so this is P slash A. Find P given A. So P slash A, comma, I equals 8%, comma, N equals 3. So if you go down to the table, you find the P slash A column, and you go down to row 3, and you'll find the lookup factor. So let's see what that is. Okay, so here's the present worth column. Find the present worth of an annual series. Find P given A. So this is the column that we use. N equals 3. So 2.5771 is our factor. Okay, so P is 2.5771 times A. So 12,500 times 2.5771. All right, so 32,214. And again, I'm going to emphasize this important point. In a problem like this, if you're doing your homework or you're doing an exam, don't just write the answer on the page. I mean, if it's right, you know, good for you, but everyone is going to make mistakes this semester, and so it's if you want to learn to be an engineer who communicates well and is able to work in teams and provide good documentation for your solutions, it's important for your solution to be kind of meticulous and show the development of the thinking. And so just writing the answer itself isn't nearly as valuable as showing how you got it and what's the supporting ideas. And so to that end, the first row is summarizing the problem statement. It's a P slash A, find P given A, 8%, N equals 3, and then stating what that factor is. And so you can notice the parentheses all around this implies we want to know what's the factor of P divided by A. So then if you want to find P for a known A, you multiply the A amount by the factor itself. And so 32,214. So 1, 2, 3, 4, 5 digits in our factor, and we've expressed the answer to the nearest 5 digits. All right, third and final problem. Let me pause for a moment and give you a chance to calculate A on this one. All right, so the question is asking to find A using the equation method. All right, so look at the interest rate, 11.5%. Our textbook has a 10% table, and it has an 11% table and a 12% table, but there isn't a table in our book for 11.5% interest. So even if we wanted to use the factor method for this problem, we wouldn't be able to because it's kind of an odd number. There's usually only factor tables for like a nice round interest rate. And 11.5 is odd enough that we're going to have to use the equation method instead. Okay, so this is find A given P. And so let's go to these equations. Find A given P. So it is this formula, the capital recovery formula. So you're going to have I is 0.115, N is 3, and so we need to solve this complicated equation here, and then that will be, whatever you get out of that equation, is the ratio of A to P. Okay, let me show you. Good, that's going. All right, so summarizing what we're doing here in the language of engineering economy, this is an A/P problem at an interest rate of 11.5%, N equals 3. So this is the equation we're using. You can see that I've made the substitutions, and then rather than going straight to the answer, I also say, all right, well, what's the result of the numerator? What's the result of the denominator? And the reason for those intermediate steps is it's such a good idea to double check your work in homework or an exam. You know, just run through the calculations a second time, and if you have these intermediate amounts written down, then it gives you an easier time to confirm that every step of your solution is correct. So the factor that we've calculated is 0.412776. Okay, so this is the factor, and so if we want to find A, then we will multiply the P times that factor. So it's going to be 7,500 times 0.412776. So, and that continues on. The little dot, 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 that means I still have all the precision in my calculator, therefore I'm going to report this answer to the nearest penny. I've used the equation method that allows me to do that. So if you deposit $7,500 now and you want to make 3 annual withdrawals, then you can withdraw $3,095.82. All right, so any questions on that example? We are going to continue talking about these interest factors in future classes. This is important stuff. So we'll continue on with it on Friday. Before we go, though, let's just refresh our memory that the next thing on your plate is homework number 2. That's due on Friday the 11th. So if you have any questions on that, you can get in touch with me on Teams. I have fluid mechanics lab this afternoon, so I'll be in and out of the office because of that, but even if it's not my office hours, I'm willing to pick up if I'm available. So you can send me an email, reach out on Teams, whatever you need. I'm here to help. Otherwise, hope you have a great day. I'll see you on Friday. Thanks a lot. Bye.